Hey grade 10s, today is a trig day. It's Wednesday at 7:30. We will be doing the other options for trigonometry, not just tangent. And then there's not a bunch of work, but I mean as much as you feel you need, because trig is really, you have three choices: sine, cosine, or tangent, which we're going to talk about sine and cosine today. But they work the same way, you just hit a different button on your calculator. So, let us get down to it. I hope you're all done your systems test. Alrighty. Here we go. So, we have dealt with this. So, if I have a theta down here and this side is 12, we can find this side if I know that degree. So, of course, if I'm working with that theta and that side, then tan of 35 equals 12 over x. So x equals 12 over tan 35. And I just punch that into my calculator. Remember, forwards calculator, 12 divided by tan 35. Backwards calculator, 12 divided by 35 tan. And then you got to hit equals at the end of it all. Now, what if I was up here? How big is that angle? Well, I know that the angles in a triangle add up to 180. There's 90 of them. So these two angles have to add up to 90, which makes this angle automatically 55 degrees. So if I'm working with red theta, it's tan 55, and that would equal x over 12 because it's opposite. So I go to the other side, and then 12 times tan 55 will equal x. And you will see, if I did that on my calculator, you would get the exact same answer. Now, I'm going to do that on my calculator, but I'm not going to be doing any more calculator work today. I'm just going to get it to here, to this point right here, when you can punch it into your calculator. So watch. 12 divided by tan 35, 17.13. And then over here in red, 12 times tan 55, 17.137. See, it's the same answer. So it just depends on which angle of the triangle you're working with. Now, you're smart kids. We know that tan of any theta is opposite over adjacent. And we remember these are both legs. Now, what if you're dealing with a triangle that you need a hypotenuse? Well, you're smart kids. Tan only deals with, I should have colored that with yellow, tan only deals with legs, those two sides. It's never the hypotenuse. So, fortunately, we have rules that work with the hypotenuse as well. The sine ratio. So, I'm going to be doing this from this theta, because theta is black. Sine ratio compares the opposite side. Now, what does opposite mean? It means across. It compares the opposite side to the hypotenuse, which in our triangle up here is the yellow one. So, sine theta equals opposite over hypotenuse. Then, cosine theta, duh, if sine is opposite, cosine means adjacent. And remember, adjacent is the leg, not the hypotenuse. The leg beside theta. And I compare that to the hypotenuse. So cos theta equals adjacent over hypotenuse. And that sets up this memory word, this mnemonic device. And all that stands for is everything I've written there. Sine, and I'm writing sin because that's the button on your calculator. Sin equals opposite and hypotenuse. Cos equals adjacent and hypotenuse. And tan, which we already know, is opposite and adjacent. Now, in this big empty space here, I'm going to draw a big triangle and show you how this works. Now, I'm not going to label or put numbers in, and you're going to see why in a second. I'm going to put A, B, C. Now, when we're doing triangles, we always name the corners with capital letters, and we always name the sides by the letter that is opposite from them. So if I want to name this side, I got to go opposite, which means I go across the triangle and I see A. So this side is little a. That's how we do it. So this side across from B is little b, and this side, the hypotenuse, because it's across from the right angle, is little c. Now watch what happens. If I work with A, here's theta, which means there I am with my gray hair and my big beard. Morning. There I am. That means A is opposite. So if I'm working down here from A, then the sine of A, and I should be doing this in blue, the sine of A is opposite over hypotenuse. What's opposite? Little a. What's the hypotenuse? Little c. Now I didn't put numbers in there because this is always true. If I had numbers in there, I would put numbers where I needed them. The cosine of A is adjacent over hypotenuse, which is of course little b over c. And the tan of A is of course opposite over adjacent, which is b over a. Now, easy peasy lemon squeezy. What happens if I take a walk up to B now I'm up here. Now B is the opposite. So if I'm working with red theta, sine of B, because that's the angle, is still opposite over hypotenuse, but now it's B over C. The cosine of B, still adjacent, but now it's A over C because I moved, so I have a different opposite and adjacent. You'll notice that the hypotenuse never changes. And tan of B, still opposite over adjacent, but now it's B over A. And that's all you have to do trig. Once you have a triangle, you have it. All you have to do is set up opposite, adjacent, and hypotenuse. So, let's look at this very first one. Remember, I have a triangle. Do I have a theta? Is there an angle that I care about? Yeah, right there. So it's 12. Once I've established theta, that means that is where I am looking at the triangle. Oh, look, I left half my hair up there. It's just like real life. I'm going bald. So here I am right here. This means this is how I look at the triangle. So that means I look across. So I see opposite is x. And I have a hypotenuse, which is 25. What uses O and H? So I go up to my line. Oh, that's sine, of course. Sine theta equals O over H. And then you just fill in the numbers. Sine 12 equals x over 25. When the number's on the bottom, we know to multiply. So 25 times sine 12 equals x. And that's what you're going to punch in on your calculator. So I said I wasn't going to do it, but I might as well. I have a forward calculator. 25 sine 12. Enter. 5.19. So 5.2. Done. Now let's go on to this side. Is there a theta? Is there an angle that we care about? Yeah, right there. It equals 19. Once I've got theta, that's where I live. There I am. So what do I have now? I have this, which is the leg beside me. So that means it's adjacent. That equals 40. And that still across from the 90 degree, so my hypotenuse equals x. So what uses A and H? I look, I see that it's cosine. So I will go, I don't know why that's there. Cos theta equals A over H. Cos 19 equals 40 over x. When the x is on the bottom, it's division, so x equals 40 divided by cos 19, which, when I go to my calculator, 40 divided by cos 19, close the brackets, 42.3. And lastly, do I have a theta? I do. There's an angle I care about, but I don't know what it is. It's x. So here I am. Now, what do I have here? I have an adjacent of 13 and a hypotenuse of 22. Well, we know that's cos. Cos theta equals A over H. Cos theta equals 13 over 22. Now this time I don't know the angle, so I have to do shift cos, just like when I was doing this with tangent. So I go to my calculator. Shift, for me it's second cos, bracket, or just punch in what I see. 13 divided by 22, close brackets, equals 54 degrees. Now remember, if you've got a backwards calculator, you've got to reverse that. You would go with a backwards calculator, a back calc. You would go bracket 13 divided by 22, close brackets, shift cos. And sometimes you need to push equals and sometimes you don't. But you need those brackets. Alrighty. Now, there's a bunch of puzzle sheets and stuff for you to practice this. Do as much or as little as you want. I'm going to skip to page 246, which is the next bit of work, but all it is what we were just talking about. So on this page, you can see if you're going to do only one page of work, then do page 246 or 261. Just do this. If you're not going to do the puzzle sheets, just do this. All right. But trig is really important going forward, so I would suggest you practice it a little bit. So here's our triangle. What do I know about our triangle? Well, I know that there's a theta of 65, which means right there is where I am. There's my gray hair, there's my big gray beard, and there we go. So that's where I live. So once I've established theta, I look. What's that? I'll pause for a second for you to think about it. You should be thinking, oh, you're looking across the triangle. So that must be an opposite, must equal 41. That's all you know. What am I asking you to do? I'm asking you to solve the triangle. What does that mean? That means find all angles and all sides. So this is where trig gets tricky for people because they're like, ooh, show me how to do it. There's no right order to do this in. You can do this in any order you want, which is why you guys get stressed about it because you have to think. You do the order. So what I personally will do is I want to practice as much trig as possible. So I'm going to call this the hypotenuse, and I know that the hypotenuse is little b because it's across from big B. And this side is the adjacent side. But I also know that it's little c because it's across from big C. So now all I do is I make my choices. What do I want to find first? Well, I'm going to find the hypotenuse first. So my hypotenuse equals little b because it's across from big B. Now, I've done this on purpose because you're used to the hypotenuse being c and a squared, b squared, c squared. But I hate that because if we change the letters and all of a sudden you can't do Pythagoras, and that math is like 4,000 years old, so you really should be able to do it. But that's why I've changed the letters around. Anyways, so now I have O, H, and theta. What uses O and H? Well, that is sine theta is O over H, which is sine 65 equals 41 over B. So B equals 41 divided by sine 65. So I do that with my calculator, 41 divided by sine 65, and I get 45.2. And then I think to myself, make sure that makes sense. Okay, well, it's the hypotenuse, so it has to be the longest side. This is not a very big angle, so these two will probably be pretty close. 45, 41, yeah, I'm happy with that. So now I know my hypotenuse. It's right there. So next, I'm going to change color. I still have a theta of 65. I still have an opposite of 41. And now I need an adjacent, which is little c. I'm not using 45.2 here because that's not the real answer. The real answer, if you remember, is way bigger. I only wrote 45.2 to have an answer for math class, okay? So I want to keep using 41 because that's an exact number. So what uses O and A? Well, that's tan theta equals O over A. Tan 65 equals 41 over C. So again, C equals 41 divided by tan 65. Now, could I have used cosine because I had my hypotenuse now? Yes, I could have. Could I have used Pythagoras because I had my hypotenuse and that side? Yes, I could have. It's totally up to you. So, of course, then our answer is 41 divided by tan 65. And I get 19.1. That's this side. Now, I've got 41, 45, 19.1. I've got all my sides, 65. I'm missing one angle. Well, we remember that the angles add to 180. So, B plus A plus C has to equal 180. B is 90. So 90 plus A plus C has to equal 180. A is 65. So 155 plus C has to equal 180. So C has to equal 25 degrees. Now, of course, the smart ones are seeing, hey, that's always 90, so I don't really need to care about that, right? I know that A plus C had to equal 90, so I can just use those two. Okay, so go practice some trig.